Swayam Prabha. Digital India. Educated India.
Hello everyone. So today we will start with network security. Okay, so we are going to start with network security today. All of you have networks background. Anyone without networks background? Okay, good. Without the background, it will be harder to follow these lectures. So this network security, all of you know what a network is. So what does network security mean? So there are these machines that are network connected. So this is the network for which they are connected, and you want to prevent unauthorized access to these resources which are network accessible, which is all these computers, but there are also, in order to interconnect them, you must have seen that there are routers, there are switches and so on involved. So even those you want to prevent someone to misuse them. That's basically what network security is. Okay. Now with respect to network security, again you have heard this term CIA, right? Everyone has heard what is C? Confidentiality. I is integrity. A is? That's what you probably have heard, but A in the CIA stands for availability, okay, not authentication. Integrity in general subsumes authentication also, in the sense integrity is not just you modifying the content within a message, which is the data integrity, but also ensuring that this packet or message has indeed come from the right person who is sending this message. It is not someone pretending to send this message. That is called source integrity. Somehow integrity will cover, source integrity is what is called authentication in some sense. Okay, so that is part of integrity itself. The A here is availability, that resources are available for people to use. Okay, so that is the CIA. Now based on your, you have all learnt networks. Have you seen any confidentiality being covered as part of your network course? How? Or if not, fine, it was not. If it was covered, where did you see confidentiality? All these network protocols that were designed, do they provide confidentiality? As part of your network course, you have covered a lot of network protocols. Have you seen any aspect of confidentiality anywhere? SSL is what you are saying. Okay. So people have used HTTP, you access it like this. There is also HTTPS, which you access like this. The moment S comes into place, when you are accessing a web, the S brings in security and there confidentiality is there. But HTTPS is a recent addition. In the past, when internet was being designed, people paid absolutely no attention to security. So lot of stuff that has happened there is no confidentiality per se. This HTTPS was a recent addition. Okay, until 5-10 years back, most websites were HTTP only. Only recently you are seeing lot of more of HTTPS. What about integrity? Have you seen in networks any mechanisms that provide integrity? So you have heard of checksum, right? But is checksum really, what exactly is checksum doing? So the idea of checksum, one has to be clear. So the checksum that network protocols provide are not security related. It is mainly provided to ensure that in case there are errors in the bits, you are able to detect. So, it is more an error detection mechanism and not quite for security. Security requires a much stronger mechanism, and that is something which you have covered as part of hashes, MACs and digital signatures. Okay? So, that type of things again you would not have seen again recently with HTTPS and a few other protocols. These are coming into play, but earlier again integrity also, there was no security aspect of integrity was also not there as part of the internet. Okay? What about availability? Have you seen aspects of where people tried to provide availability as part of the network course? Networks course, we do not cover data centers at all. So, availability is about ensuring some reliability of whatever you are doing, right. So, a lot of network protocols, for example, have some aspects of it where they deal this with in distributed settings. So, for example, when you are connecting networks, you will have redundant switches or redundant paths. So, in case some router breaks or switch breaks, you find an alternate path. So, these are all also aspects of availability in the sense that they are trying to ensure that even if some things break, be it for a genuine reason or some attacker has brought down some system, there is alternates to this. So, that is the aspect. So, availability to some extent has been provided in the design of this internet and networks, mainly through distributed operations. You distribute it and ensure that even if some things break, there is some recovery from it. So, that is how network protocols are typically designed. So, anyway, this is the background of the current state of the art. Things are not as bad as they were earlier. So, right now, for example, at the application layer, you would have seen SSH protocol. What is it used for? What does it do?
It's like a compiler.
Compiler? Remote login. So, basically in the past people used to use telnet, which was not secure. SSH is about logging in remotely to some other machine to do some sysad or whatever it is, or to recover or do share some files, do there, and it is a remote access to a machine. That is what SSH does. In the past it was telnet. SSH is again a secure login. Okay, so that is something that you must have seen. At the transport layer, again when we talk about this HTTPS, in fact that is not an application level security mechanism, it is actually a transport layer security mechanism where you are using this thing called TLS or SSL. This is a transport layer protocol which was built on top of the TCP protocol, which provides security. Okay, so that is something that people have introduced. At the network layer as well, you have IPsec, which is ensures that all the network layer packets itself are protected. Again, it provides confidentiality, integrity and so on. That is through the IPsec. And at the link layer, what are the link layer technologies people are aware of? What link layer technology do you know? Is there any link layer technology you are aware of? What is it? It is a protocol technology I am asking. So, a technology is like link layer is basically giving you access to some communication. What link layer technology have you used? You are all using it right now. Maybe not right now, whatever. Link layer technology in the lab you definitely have used it. What is it? So, one Wi-Fi is one link layer technology, and similarly Ethernet is another link layer technology. Ethernet is a wire, Wi-Fi is a wireless technology. Okay. Now, even here as of now Ethernet still does not implement any major security. There is no confidentiality, integrity when things go over a wire, because it is much harder to eavesdrop and modify things when things are going on Ethernet, but Wi-Fi is open. When someone transmits, everyone can listen. So, their confidentiality, integrity play a much bigger role. Okay, so accordingly at link layer also there have been these WEP, WPA and so on. So, these I do not know how many of you have actually used Wireshark. If you try to run a Wireshark trace on what is happening on the Wi-Fi, you will actually see you can't really see much. Other than the link layer header, nothing else you can see. Why? Because it's been encrypted with this WEP or WPA link layer security mechanisms. Okay? So, this is roughly the current state. What we are going to do today is the following. So, we will start out with the nature of attacks, then we are going to go up the protocol stack, where we will start with link layer, cover some attacks at the link layer and also defenses, then we will cover something at the network layer and then transport layer and then the application layer. Okay. So, we will take some, again this is a huge topic, again we have only 3 hours. So, we will just take some specific protocol which you are probably aware of. I will give some background about that protocol and then we will see what vulnerabilities that protocol has, how attackers exploit that vulnerability and how to defend against that vulnerability also. So, that is the plan for today. Finally, we will also talk about firewalls, time permitting intrusion detection systems, but these are again defenses against some of these things. So, that is the plan for today. So, now what we are going to see is what is the composition of an attack. Okay. So, before we cover this, suppose you want to rob a bank. Okay, I am not expecting you to really rob, but think about robbing a bank. What do you do? What are the steps? If you want to rob a bank, what do you do first?
Firstly, the map of the bank.
Huh?
Map of the bank. We track the location of the
So, basically you do, generally you see where is the bank, where is security, when are they changing their shift. Okay, this is all called reconnaissance. Maybe my spelling is wrong, but anyway, so that is the reconnaissance part of it. What else then? Let us say you figured out based on this that something is basically you figured out some details about, then what do you do? Okay, you take a gun. What else? So, basically one is this reconnaissance, whatever it is, then so fine, how do you decide, even before you do it, do you just go like that or you will mask? You are going to cover your tracks, your identity has to be, otherwise the CC cameras, whatever it is, whatever is there, you just do not want people to recognize who you are. So, you are definitely going to cover your tracks and then like as you said, you are going to exploit some vulnerability, be it that locker is whatever is not good or blast the locker, whatever it is, something is not right with the bank, you are exploiting that weakness in the bank and then you are going to launch an attack. So, basically this is how things happen. So, in the network also what happens is kind of very similar, where you are going to do scanning and sniffing. In fact, today's lab you will do both of them. Okay. So, scanning and sniffing is one of the first things you do in the network side. You want to figure out what are all the machines that are there, what services are running on those machines, okay, what is the traffic that is being exchanged. So, this is all the record. So, this is basically gives you an idea of what defenses are there, what services are running, if they have any vulnerabilities and so on. Okay. Then the next thing you will do is covering your track is often goes by the name of spoofing here. Okay. So, basically spoofing means you take on someone else's identity so that you are not caught. Okay. So, basically if you are sending a packet you won't send your own IP address within that. You will take on someone else's IP address and send that particular packet. That way, if at all someone gets caught, the other person will get caught, not you. Okay, so that's the basic idea. And of course, the third is you will exploit some vulnerability in the particular protocol or system. This we will see more of it when we cover the link layer, so what all these attacks. Okay. So, with respect to the lab, I just want to highlight that the scanning often can happen through a tool called Nmap, which is what we will see in today's lab also, and Nmap gives you lot of information. What type of information does Nmap itself give, but in general let us talk it not specific to Nmap, which anyway you will see. So, when you are scanning, what exactly can you potentially obtain? Like for example, there is a network, what all do you want to scan? Can someone tell what is it that you want to scan and figure out? Okay, so one is what are the ports that are open? So, for example, HTTP, the web server runs on port 80. Okay, so when you scan a machine, you want to know is a web server running on that particular machine. Okay, because then you may think, okay, this web server has some vulnerability, maybe I can exploit it. So, for that you really need to know whether is it an email server, is it a web server, is it an FTP server, whatever, for which based on the port you can get that information. So, the first is what are the ports that are open. Okay. What else then? What else do you like to know when you are scanning a network? So, how do you determine that security level? Huh? So, when we say what protocols, the port is in some sense giving you what protocol, right? Port 80 means HTTP, email means some other port, that way. Yeah, so in some sense related to ports is what are the services that are running on that port. So, oftentimes ports and services there is a strong mapping, but the mapping is not sacrosanct in the sense that port 80 typically may mean it is a web server, but there is nothing stopping you from running some other service on port 80. Okay, it is not that it is given that okay, you use port 80 means you have to only use that, it is up to you. You run a server as long as your clients know that if they use this port they can access this service. It does not necessarily mean you have to run only HTTP on whatever port 80, you could run any other service. Okay. So, oftentimes because this mapping is not, it is true to a lot of extent, but it may not be also true, in which case you could also interact with that service. You will send some message, it may not understand your message because you are just guessing, okay? But in response to that message it will send a response. It will say maybe send a response, I do not understand what you are saying, but that response will have a certain structure, and based on that structure you can determine what the service is. Okay, for example, if it is a HTTP whatever it is that is running, it may respond with some 404 whatever, you know, they are HTTP codes, right. So, it will respond with certain codes, and once you see that code pattern you know definitely okay, this is a HTTP service that is running there. Similarly, email will have a certain way it will respond. There is a packet header format. Based on that, you will figure out that this is the kind of service that is running. So, this is something that is there. What else apart from these two, what else are you interested in? This you should be able to tell in terms of certain vulnerabilities are specific to a given operating system. Like we say Windows has this vulnerability, or we will say Linux maybe has this vulnerability. Okay, so, it is also important when you are scanning to know the operating system. Okay. Now, how do you determine what operating system some machine is running? remotely, as in you are interacting with it, but somehow through that interaction you should be able to determine what operating system it is. Yeah. So what is being said is there are certain parameters of the operating system. When you interact with it, based on those parameters, you can kind of figure out. So for example, in TCP, if you are aware of, there is something called advertised window size, which is basically if you are a Windows machine, when a TCP connection is established, you allocate certain memory for storing your received packets. How much memory is being allocated, you will tell the other guy that this is the space I have in my buffer. So whatever you send, don't exceed this much space. So that is the advertised window. Now different operating systems are going to allocate different amounts of memory. Thereby, if you examine the packet, the advertised window is going to be different. So based on that, you can kind of determine whether this is a Windows machine or a Linux machine. This is one example. Like as he was mentioning, the TTL also could be another example, what values you are setting. So basically different operating systems in the packets will set different values. Based on this, you should be able to determine whether something is a Windows machine or a Linux machine. Okay, that is how you determine what the operating system is. Oftentimes, you also want to get some information about the topology. How are things interconnected? Okay, so for example, if I am here sitting somewhere and I am trying to access, let's say, some IITB web server, I may want to get a sense of where is this IITB web server, how many routers are in between. Based on that, it will decide what my attack is going to be. Okay, so topology is also something that you want, and oftentimes things like trace route, whether that machine is even up or down, which through the use of ping you can determine. Okay, so this is all in the scanning and sniffing kind of a phase. Spoofing is basically taking on someone's IP address or MAC address, which is kind of straightforward. If you have root access, you can always construct packets where the header fields or whatever you want. Okay, so that is, and again this exploitation, as I said, we will cover it based on the specific whatever protocol. So with this background, I think now we are ready to cover individual protocols. Okay. So with this, let's start, as I said, layer by layer. We'll start at the lowest layer, which is the link layer, and then we are going to go up the layers, and at each layer we will cover one specific protocol and whatever vulnerabilities that are there. So at the link layer, in fact, I'll cover two. So one is, before I get into that particular drawback, let me first explain some things related to link layer. I'm not sure whether you have the right understanding. At link layer, you may have heard that we use what are called switches, right? People know what the difference between a switch and a router is?
This one.
You know, what is it?
I'm in all the networks.
So basically the answer is that router operates at the network layer, switch basically in our terminology is going to operate at the link layer. Link layer means it will examine which header, link layer header, and what is the address it will see. IP address it will see and act on it. Will a switch look at an IP address and act?
No, MAC.
It will look at MAC address, because MAC is the address that is at the link layer. Okay? And you may have seen that in whatever Ethernet, there are all these switches. So switches, I don't know how many of you have seen a switch. A switch has lot of ports and you plug in Ethernet into it. So for example, there is an Ethernet port there, behind it there is a switch, somewhere it is leading. Okay? So you have a switch with lot of ports and you plug your machine into that. Okay? So here is a switch, so here is one computer, many computers, like depending on how many ports are there are 24 port switches, 36 port switches and so on, you connect, and these switches are connected like this. Okay, these are all machines, and one of the switch may be connected to a router, which will in turn connect you to the outside thing. Now, as far as these switches are concerned, if I say this, these are A, B, C, D, whatever it is, A, B, C, D, we consider them as neighbors. Even though they are interconnected by multiple switches, as far as the link layer is concerned, there are your neighbors still. In fact, you can abstract it out as a bus and say these are all your neighbors, like this. By what I mean by a neighbor is that in case you send a broadcast packet, okay, broadcast means give it to all my neighbors. If A were to send a broadcast packet, B, C, D, in fact every machine that is connected to the switch will get that broadcast packet. But through the router, if there is some switch here and there is a machine called X, X will not receive that broadcast packet because it is not a neighbor. It's been separated by a router. That means the domain is different. Okay. Now, in link layer, there are again two things we should be aware of. One is called something called learning bridges. So, switches are also called bridges. Bridges and switches mean the same, but I am going to use the word bridge now on because that is the terminology we use for learning bridges. People know what learning bridges are. Suppose A were to send a packet to D, if there was no learning, what will the switch do is it will just broadcast everywhere. So, it will get a packet from A, it does not know where B, D, whatever A is sending a packet to D, that is what we are covering, A is sending a packet to D, because it does not know where D is, it will send it out on all the ports. Then this switch will get, then it will send out like this, finally this switch will get, it will send out like this, and finally D will get the packet. All the others will ignore the packet because the destination is not them. Only D will interpret the packet because the destination is, but everyone will get the packet. Now, this, as you can see, violates in some sense confidentiality. You do not want, you are now getting to see whatever is happening, anyone sends any packet, you can examine that packet and so on. Okay. Learning, by the way, when learning bridges were designed, that was not the criteria, security was not the criteria. They just worried that this is just going to waste what? If you do this broadcast, what will happen to the network? Huh? Bandwidth predominantly, bandwidth is going to be where you are just doing unnecessary work, sending packets on the wire which you do not have to send because the packet that D is not in that direction. Okay? So, what learning bridges are going to do is they will learn where this D is. How do they learn? So, for example, A is sent a packet, let us say it got broadcasted, finally D got a packet. Now, D, when it sends a reply, this switch, let me call it S1, this switch S1 will know that I received a packet with the source as D on this particular port, let me call it port 0. So, S1 will maintain a table saying on port 0 D is there. It has learnt. Now, this is going to forward it like this, let me call this port 1 of this switch 2. Now, S2 will now put an entry that says on port 1 towards, because it received the packet in that direction, it will say D is in that direction. That is called learning, it is learning, and finally this packet will reach A, and now when A sends another packet to D, it will not get broadcast like this, it will take on the path it has learnt. Okay, those are called what is called learning bridges. Okay. Now, learning bridges, this is an optimization basically. You want to reduce the bandwidth consumption. People have designed these learning bridges that are part of the switching. Okay. Now, with learning bridges, now let us bring in attacker. Suppose let us say there is an attacker, let me call it Mallory, that is sitting here. Okay. Now, A has sent a packet to D, same situation as before, but Mallory wants to see what this packet is. Okay, generally to see what, I mean, it's a violation of confidentiality, so she wants to see what this packet is. Now, if learning bridges were in place, can Mallory see this packet? No, because that packet will take, it will go on this port, then it will go on this port, and it will go on this port, and so on. It is definitely not going to come on this port. But Mallory wants to see that packet. Now, what can Mallory do to see the packet? Okay, so that is the attack it wants to launch. So, let us understand how Mallory can potentially do that. So, for that we need to understand a few things. So, these switches that are there, they have certain memory that is allocated for them, and this memory is being used to maintain this table. It will tell, okay, on port 1 you can reach C, on port 2 you can reach D, on port 3 you can reach A, whatever. So, that is the memory they are maintaining. With this memory they are learning and maintaining, and there is only a fixed amount of memory. You do not allocate infinite memory. In fact, there will not be any infinite memory. There is a fixed amount of memory that the switches are going to maintain. Now, there are 2 points for you to note here. One point is that they are doing this. Second is, if a switch, so first is there is memory related to this is what you are doing. The second is that in case, so the switch receives a packet with the destination address as, let us say, X, and there is no entry for X within its table, what will the switch do? Remember, this is an optimization, this is not for correctness. The default behavior is, if you do not see that entry, you will flood, you will send it out on all your ports, because you do not know where that particular destination is. You can't drop the packet, you have to serve, so you will send it out on all the ports if this is not there, but if it is there, you will send it on the designated port. So, that is the how the switching is happening. So, let me reiterate, that is the switching, that is how it happens, and switches have a fixed amount of memory to store this. With this too as a background, if you, Mallory, wants to see what is happening, a packet that A sent to D, it wants to eavesdrop on that particular packet, what can Mallory do? It has to fill up that table. How will it fill up the table? So, basically this switch S to which it is connected, it will keep sending packets. It will send a packet saying my destination, whatever source address is X, some destination does not really matter, some destination it will put and send a packet. Then it will send another packet, my source address is Y, it will send this packet. So, this switch S now will have entries X, Y, whatever, Z, P, Q, R, whatever it is, are all on this port, let me call it port 5, they are all on this port. Okay. If it sent 1000 packets with 1000 different addresses, 1000 entries will get filled. If it sent 10,000 packets, 10,000 entries will get filled. The moment you exhaust that table with this spurious entries, you have no more space to store the correct address to D. Okay? Then when a packet comes to D, there is nothing in the table, then you will flood, which means you will send it out on this and Mallory can see the packet. Is it clear what has happened here? Okay, so that is one way in which you can eavesdrop on a link layer. Okay. Now, what is the defense against this? One port can have only one, that is the suggestion, that you can only learn one MAC address from one port. Will it work? Let us take a switch like this switch, S1 switch, which is connected to S2. So, this port, which is port 1 of S2, can you put a restriction saying you will only learn one MAC address from that port? Can you learn or no? Remember, this switch S1 again depends upon how many it may have. In this particular case, if this switch S1 may be connected to some 32 hosts, all of them will use this. If you have to send to anything, they will all be sent like this. So S2 has to have entries for all the 32 hosts, and all of them will be port 1 only. So you can't generally tell switch 2 put 1 restriction that it will only learn one address there. That's not going to work out. But what you are saying is almost true, but you have to add an extra condition which sysads will know. What is that extra condition? So when sysads are interconnecting the switches, they know whether a port is being connected to another switch or it is being connected to an end user, right? So these type of attacks are launched by end users, they are not other switch, they are under control of the sysads. Okay, so all you need to do is ensure that if it is connected to an end host, if not 1, 2, let's say only 5 addresses or something, it will learn from that. That's it. This is called MAC limiting. This is a defense where you will tell I will only allow only this much learning from that port provided it is connected to an end user. Other switches you can't put this restriction because you can learn any number of addresses from that particular other switch. Okay, so that's the basic idea. Just to again summarize, this attack goes by the name called MAC flooding, where the purpose of this attack is to eavesdrop, and the defense for this is the MAC limiting. Okay, any questions on this? So this is a switch level defense. By the way, there are also higher level. For example, if you use HTTPS, for example, it inherently provides confidentiality. So even if Mallory were to get hold of the packet, she cannot see what is inside the packet because it's all encrypted. So that is also there. But in case for whatever reason you are not using application level security or transport layer security, this is another defense for MAC flooding done at the switch layer. Okay. Okay, let's look at another attack at the link layer. So we have seen an eavesdropping attack. Now we are going to look at a spoofing attack. Okay, this goes by the name of ARP spoofing. ARP protocol, everyone knows what is the role of ARP. You have the MAC address, you are looking for IP. Is that what you are saying? What does ARP do? ARP protocol, what is its role? Find the, for what? For a given IP address. Okay. So the reason again why this arises is, so for example, this is your machine. Okay. Now in the browser, let's say I have typed www.iitb.ac.in. When I type this in the browser, again this as a human I can remember iitb.ac.in, but if it's some number I won't be able to remember. So that is why I use this. Now the browser, you may have heard of this other service called DNS, which again we will cover slightly later, is going to ask this DNS telling this is the name I know, give me its IP address. Okay, so DNS will say okay, IP address is let's say 10.5.6.7. Now my machine is then going to generate a packet with source as my machine's IP address, let me call it IPS, and destination as 10.5.6.7. Okay, this is being done at the network layer, and then it will pass it to the link layer. Okay. Now what does the link layer do? It needs to send this to the particular machine. Again then there are some subtleties here. Suppose this IITB, so this is my local area network. Okay. There is some router which is connecting to another local area network. As I mentioned, all the hosts that are part of this are my neighbors, whereas something here is not my neighbor. Now it depends whether this is my neighbor or not. Is it part of my local area network, or is it sitting, is this IITB or is this the IITB? Let us say if this is, let me call this A. So if A is sitting here, is this the IITB or is this the IITB? We do not really know as such. Okay? So what the network layer will identify is based on, so there is again some of this you should know, there is some concept of subnet. So when you are setting up your IP address, you will specify which subnet you belong to. Okay? When you are specifying your IP address, you have to specify that. Based on that, the network itself can determine whether this IP address is within your local area network or outside your local area network, because if the subnets match, that means it is your neighbor, otherwise it is not your neighbor. Okay? Based on this, the network layer will figure out. So for now, if you do not understand it, just assume that network layer somehow has the mechanism in place to tell whether this host belonging to this IP address is in your local area network or outside your local area network. If it is within your local area network, which is, let us say this is where the IITB server is, then it knows its IP address, but it does not know its MAC address. Link layer, you have to transfer it, you have to specify the MAC address, because switches will send it through the MAC address, they are not going to look at the IP address. So in order for A to determine its MAC address, A will send out an ARP request, which is basically a broadcast. So again here lot of people get confused. There is a link layer header, and there is inside the link layer header there is an ARP packet. In the link layer header, the source will be A, whereas the destination will be broadcast. Okay? And in the ARP packet, it will say that this is my source IP, which is IP A, and this is my MAC, which is MAC A. And then it will say, I want to know whatever this destination IP, this is maybe IP, I am calling it B to indicate IIT Bombay, MAC, I do not know, you tell me. This is what is inside the ARP packet. This goes out as a broadcast, that means everyone, all the switches will send it out on all the ports, and finally this packet will be received by IITB server. IITB server will say, okay, someone is inquiring about my IP, they will fill this entry and reply back with an ARP reply. Okay. Now based on this, A will now it will have something called an ARP cache, where within the cache it will say this 10.5.6.7 has a MAC address corresponding to that particular server. It will save it. Okay. So this is how ARP protocol works. Any questions on this? It's clear? Okay. Now this, it so happened that the IIT Bombay was within the local area network. It is possible that it is outside also. If it were outside, again the network layer will tell that this is not within your local area network, it is outside. Then also you may invoke ARP if the entry is not cached, but there what ARP will you invoke? Whose IP address are you going to ask, as in whose MAC are you going to ask for whose IP? Huh? Web server is not in your local area network. There is no point in asking because it is not there within your, if you broadcast, no one will reply because it is not there as part of your local area network. But the packet still has to go outside. So in this case, ARP is invoked, but ARP will ask for whose MAC corresponding whose IP? The router. Since you don't know how to send this packet, your best bet is the router. Router will figure out. Because it's not part of your local area network, it's now the responsibility of the router to Okay. So it is the job of the router now to take care of this packet. So in the ARP you basically will say again same here, whereas the destination IP you will put the router's IP and say what is its MAC, and the router will reply. But oftentimes these requests you don't see often because the cache will invariably always have the IP of the router and the MAC of it cached. These are not evicted as often because for any outside communication you anyway have to contact the router all the time. So the router's thing will often be cached. Okay, so that's what is happening. Anyway, this is ARP protocol. So the high level point takeaway from this ARP protocol is that, again let me tell a little bit more, then I will summarize. In terms of security, when you look at this ARP protocol, we call ARP as a stateless protocol. What I mean by a stateless is that whenever it receives a reply, and within the reply there is an entry which says this IP address, this is the MAC corresponding to it. Okay, someone has replied with that response that this is the IP address, this is the MAC. When we say stateless, ARP doesn't remember, did I send a request in the past, is this reply come for that request? It doesn't remember all that. It just sees this packet. In this packet, it sees an IP address and MAC pairing, it will just put it in its cache. Without care or concern who sent this reply, did I ask for it, nothing it will remember, because stateless protocols are basically very easy to implement. You don't need to have any major logic and all. You get the packet, you see what is in there and update your state, update your cache rather. Okay, so stateless protocols are very easy to implement because the logic is very simple, and that is how ARP was implemented because they didn't care for security much at that time. But now you can see what the problem is. What is the problem? Yeah, so basically if Mallory were to create this reply and mapped, let's say, the router's IP address with its own MAC and send it to Alice, which is A, Alice will put it nicely. And remember, if you are spoofing, so here basically Mallory is spoofing the router. And this can be an extremely dangerous thing because whatever communication you are having with the outside world, everything will go through the router. And if Mallory were to spoof the router's IP address, where the router, it is basically telling I am the MAC of mine, which is Mallory's, corresponds to the router's IP address. Now Alice will construct a link layer packet with the destination as Mallory's MAC, even though it wants to send this packet to the router. Then Mallory will get hold of the packet. In fact, any outside, all packets of Alice which are going to the outside world, Mallory can capture it. This is happening mainly because ARP is a stateless protocol which does not care whatever packet it gets, it is going to kind of save it and change the entry. Okay? So this is called ARP spoofing, where someone, in this case Mallory, is going to construct this spoofed reply and send it, and Alice will cache it. Okay? So this is the concept of ARP spoofing. Within ARP spoofing, there is also something called man in the middle attack. So in this case, what is happening is, so this is Mallory, this is A, this is B. Okay? So Mallory has set itself in between, so A and B want to talk with each other and Mallory has come in between. What Mallory will tell A is IP address of B corresponds to MAC address of M. So basically it is telling A, if you want to reach B, use this MAC, which is its own MAC. So whatever packets A sends are going to go to Mallory. Mallory will examine these packets and it won't drop the packets or anything. It will pass it nicely to B as well. And similarly, Mallory will tell B that IP address of A also belongs to MAC of M. Now B, when it replies, this packet also will come to M. M will again examine the packet and send it to A. Now as far as A and B are concerned, if at all B checked on A later saying, did you really send that packet? Yeah, it will say I sent, and both are in agreement because Mallory is only sitting in the middle reading all the packets, not dropping the packets. So they both think they are communicating with each other. There is no drop of packets to show malicious behavior, but then Mallory is reading all the packets. So this is the man in the middle attack. So through ARP spoofing, you can potentially achieve this man in the middle as well. Okay, where the Mallory is now going to, so how is this attack basically launched is, Mallory will just construct these ARP replies and periodically send them to both A and B. It is possible that the actual B at some point may also send an ARP reply. So it may get installed in the cache, but once Mallory sends this periodic, it will get overwritten. So the Mallory's job is to continuously send these things such that in the cache you have this mapping, whatever the malicious mapping you want. So that is how the attacks are launched. And the objective for this is, as I said, you are using spoofing to achieve some kinds of eavesdropping. That's the objective. So naturally the question is, how do you prevent this attack? What can be done? So again a hint there is, the switches again have to do something clever. So oftentimes you will see link layer, the switches take on a lot of burden. In the earlier you saw that how they were MAC limiting by learning. Here also they have to observe something which is odd and then raise a flag and block stuff. What is the odd thing that the switches will see? Huh? Periodically is not the issue, that is periodicity is fine. I mean the nature of the traffic could be that periodically you may send certain thing. Periodically is not the odd one out. If for example periodicity is the odd, then Mallory will change the attack to make it aperiodic. It will send once 1 minute, once 1 minute for 50 seconds, another time 2 minutes, whatever it is. So that is very easy to circumvent. What are the switches going to see in this? So for example, let's say A is here. It is connected to some switch, which in turn is connected to some switch, which in turn is connected to B, and somewhere here is Mallory. This switch, what is it going to see? It will see something very odd. It basically is going to see where one single IP address is being associated with multiple MAC, right? So basically it will see that it is advertising this and this. It is going to see that. Any switch that is connected to Mallory will see something odd, because it is advertising, and not just that, sometimes B will also send some replies or requests where B will say IP address of B corresponds to MAC of B. Right? So it is now, switch is now going to see some very odd behavior. Same IP address, B is claiming it's MAC, Mallory is claiming it is its MAC, Mallory is also claiming someone else's IP as its MAC. So it's going to see this pattern which is not, as in it's very odd pattern. Okay? Now the switch, whenever it sees such odd pattern, it will raise a flag for a sysads to have a look. Okay? That something is happening wrong. In fact, sometimes if it sees such behavior, it can even be programmed to drop those packets. The ARP replies whatever it is corresponding to this, but oftentimes sysads, it will raise a flag, sysads will examine which port is these things are coming from, and they will take to task whatever machine is connected to that port. Okay? So this is the example of ARP spoofing. Any questions so far?